To our dear resilient and high-spirited organizers of this fourth NCMAR, the Philippine Consortium of Higher Education Institution Journal Publication Incorporated, in partnership with the Eastern Visayas State University, to the equally brilliant panel of evaluators, other research presenters, and participants who are presently watching to this very timely undertaking, a pleasant day to all of us. I am Dr. Mark Angelisiri Tutor, honored to present to you my research study modeling on the mathematics problem-solving competency of tertiary students in the new normal. One of the consequences of the COVID-19 outbreak is the closure of various academic institutions in the Philippines and other parts of the world. Frequent online trainings and workshops were conducted for teachers and students on how to shift from physical classroom environment to an online learning delivery space to avoid physical contact and interactions to lessen the spread of the virus. For this, a great chance that students may not be able to take all the important skills required in their subjects, especially in mathematics. This is because many students were struggling and experiencing stress on how to fully apprehend all their subjects, particularly those who are not fascinated with doing and learning mathematics. Mathematics plays a vital role in humans' life since it offers an operational approach and structuring and restructuring mental disciplines that boost logical reasoning and analytical thinking skills. Mathematics competency needs to be developed by learners to intensely recognize and appreciate the real context and true meaning of mathematics. The study was anchored on the learning theory, which is meant to explain and help educators understand how students best learn, involving multiple disciplines such as psychology, sociology, neuroscience, and education. This research was conducted to determine what model best explained and mathematics problem-solving competency of tertiary students during the pandemic. Specifically, it looked into the characteristics of the respondents along demographic profile, study habits, attitude toward mathematics, metacognitive skills, ICT engagement, problem-solving competency, and came up with a best fit structural model. Based on the theories presented in literature reviews, the researcher hypothesized a model showing how problem-solving competency of tertiary students along decision-making, research, team building, analysis, dependability, and intercommunication is influenced by identified latent variables such as those demographic profile, study habits, attitude towards mathematics, metacognitive skills, meta-strategy, and ICT engagement. This study utilized a quantitative method of research, specifically structural equation modeling, since in this study, it measures behaviors, attitudes, and other defined variables to quantify the degree. It involves testing theories and hypotheses about the influence of exogenous latent variables on the endogenous latent variable and coming up with a best fit model from the identified latent variables under study. 535 were included in the analysis, randomly taken from the University of Northern Philippines during the academic year 2021-2022. A set of Likert scale were considered by the researcher. Content validity was first measured in the research instrument before running to an exploratory factor analysis, and the Cronbach's alpha was also used to establish the reliability index per factor. And as a result, all factors in every latent variable except study habits, since it was adopted, have reliability indices greater than or equal to 0.70. More so, the researcher followed some ethical guidelines during the conduct of the research. The collected data were analyzed through frequencies and percentages, means, standard deviation, regression analysis, and the structural equation modeling. In determining the best fit model of the students' mathematics problem-solving competency during the pandemic, the researcher was guided by the presented model evaluation indices as Stiger and Line 1980, Bentler 1990, Bentler and Bonnet 1980 suggested. P-value less than 0.05, Simin DF less than 3.0, goodness of fit index greater than 0.95, comparative fit index greater than 0.95, normal fit index greater than 0.95, Tucker-Lewis index greater than 0.95, root mean square error approximation, or the RMSEA, less than 0.05. Moreover, the Akaike information criterion was also considered to estimate the prediction error and the quality of the created models. This criterion will be another basis for choosing the best fit model. For this criteria, it can be said that having a lower AIC value is better. Lastly, after choosing the most quality or best fit model that meets the set criteria, the researcher checked the average variance extracted and composite reliability indices per construct to evaluate the validity and reliability of the model as Forner and Lacker 1981 suggested. The study findings are as follows. A great majority of the respondents were females who belonged to the 18 to 20 age bracket and graduated from public high school. In contrast, the majority reside in rural places. The respondents have a fair study habits. They have manifested neutral attitude towards mathematics, demonstrated very good metacognitive and meta-strategy skills and ICT engagement. They are highly competent in solving problem-solving competencies, specifically along decision-making, research skill, analysis skill, and intercommunication skill. Based on the standardized regression weights of Model 1, the exogenous variables such as the demographic profile, study habits, attitude toward mathematics, meta-strategy, and ICT engagement were found to have significant positive impacts to the problem-solving competency of the respondents. In contrast, a negative significant impact was seen on their metacognitive skills. Considering the factor loadings observed in Model 1, the researcher selects only those with significant loadings, which was the basis of crafting Model 2, as shown in the slide. It can be observed that when monitoring under metacognitive, research under ICT engagement, and research and analysis skills under problem-solving competency of students were retained. It proposed that a model that satisfies all required indices, except the computed probability value of less than 0.05. The model would tell that the problem-solving competency of the tertiary students by their ICT engagement, especially when they are engaged in research and when they do constant monitoring of their learning. Considering Model 2, the researcher came up with a third model as seen in the slide. Since meta-strategy is a technique to consider in doing metacognition, the researcher have decided to integrate it as one of the possible constructs to influence problem-solving competency of the respondents. As shown, the metacognitive skill, specifically monitoring and meta-strategy skill of the respondents, were both found to be significantly impacted their extent of ICT engagement explicitly along with research engagement, which explains 77% of the variance of the problem-solving competency of the respondents. In addition, more than 0.85 factor loadings were seen in research and analysis skills as dimensions of the endogenous latent variable. Further, it can be observed that Model 3 is the fittest amongst the three created models as manifested from its computed CMIN DF, CFI, TLI, IFI, and RMSEA. As another justification, the Akaike Information Criterion Index Model 3 gives the list estimate of the prediction error of 27.646. Hence, the result suggests considering Model 3 as the most quality structural model to explain the tertiary students' mathematics problem-solving competency during the pandemic. This table displays how valid and reliable the chosen model number 3 that explains the mathematics problem-solving competency of tertiary students during the pandemic. It shows that all selected constructs were found to have greater than 0.5 average variance estimates, greater than 0.7 construct reliability indices. This means that the set criteria have met, implying that Model 3 is acceptable. As an implication, Model 3 is seen to be the best fit model. It can be said that ICT engagement greatly impacted the problem-solving competency of students during the pandemic. Without technology nowadays, it is a big challenge for students to cope with their academics, particularly in their problem-solving ability. Most of the time, they need to engage in such, since academic and learning institutions need to implement blended learning modality to deliver the instruction during the pandemic. The third model implies that, in particular, if students engage in ICT, they can manifest research and analysis skills. However, they still need to develop their metacognitive and meta-strategy skill. Hence, without this, they would not be able to demonstrate proficiency in solving mathematics-related problems. Based on the findings, the researcher forwarded the following conclusions. First, the characteristics of the students' respondents are variables and can be used for inferential analysis. The respondents manifested reasonable study habits and attitude towards mathematics. The metacognitive and meta-strategy skills and ICT engagement of the respondents are satisfying. Competence in mathematics problem-solving competency has been observed from the students during the pandemic. Model 3 was seen to be the best fit structural model for students' mathematics problem-solving competency. Based on the conclusions drawn, the researcher forwarded the following recommendation. First, since there were other factors to explain the problem-solving competency of the respondents, future researchers should consider looking for these possible demographic factors. To have a superb level of problem-solving competency, excellent study habits, and a very positive attitude toward mathematics should be exhibited. Since there is still room for improvement, instructors and professors should think other ways how to improve their metacognition, reflective thinking, and the problem-solving competency. The best fit structural model should guide instructional designers, educators, and curriculum planners to help tertiary learners further enhance their problem-solving competency, especially in mathematics-related programs and other allied fields. Another study should be conducted by doing the process of structural equation modeling to create other models that can be proposed for policy development and curriculum enhancement and later be applied in the field of mathematics education. As my final note, please allow me to share the idea from John Holt that learning is not a product of teaching, but learning is a product of activity of learners. Have a good day, everyone, and may God bless us all.